Hello and welcome to this new course. Today we will talk about ATMEGA connection. Start by connecting a 10 kilo ohm pull-up resistor to 5 volts from the reset pin in order to prevent the chip from resetting itself during manual operation. As you can see here, this is the reset pin, which is the first pin. As we mentioned in the previous lecture, you must connect a 10 kilo ohm resistor to the power 5 volts here. So as you can see, do the very same thing. This will prevent Arduino board from resetting itself. It will hold it to 5 volts using this 10 kilo ohm resistor. The reset pin reboots the chip when pulled down to ground. In later steps, we will show you how to add a reset switch that takes advantage of this and will allow you to reset your Arduino whenever it's stuck in a line of code. Now let's move forward. We have to connect pin 7 to VCC, digital supply voltage, and pin 8 to ground. We have to do the very same thing for pin 22, 21 and 20, ground, analog reference pin for ADC. You must connect it to 5 volts, and AVCC supply voltage for the ADC converter needs to be connected to power if ADC isn't being used, and to power via a low pass filter if it is. A low pass filter is a circuit that reduces noise from the power source. This example isn't using one. So just connect these 3 wires and these 2 wires. Count the pins. Start by counting from here: 1, 2, 3, 4, 5, 6, 7. Then number 7 is connected to VCC, as you can see here. Number 8 is connecting to ground, and move forward and connect these 3 pins. Now moving forward, add a 16 MHz crystal or external clock between pin 9 and 10, and add two 22 picofarad capacitors running to ground from each of those pins. As you can see here, we have the crystal between pin 9 and 10, and we have 2 capacitors. Then the other terminal of each of these capacitors is connected to ground. Add the small tactile switch. This is the switch, so that you can reset the Arduino whenever we'd like and prepare the chip for uploading a new program. A quick momentary press of this switch will reset the chip when needed. Add the switch just above the top of the ATMEGA, as you can see here in this location, crossing the gap in the breadboard. Then add a wire from the bottom left leg of the switch. As you can see here, this is the leg. This is one of the switch legs. We add this wire and connect it to the first pin where we connected the resistor in the first step. So add the switch just above the top of the ATMEGA chip, crossing the gap in the breadboard. Then add a wire from the top left or from the bottom left leg of the switch to the reset pin of the ATMEGA chip, and a wire from the top left. As you can see here, this is the top left leg of the switch to ground. So here we connected the first pin to a 10 kilo ohm resistor and to 5 volts. Now we placed the switch here, and we connected one of the switch legs to the first pin here before the resistor, and the other terminal of the switch is connected to the ground, as you can see here. So now we have a reset switch for our board. The chip used on this board is actually already programmed using the Blink LED program that comes with the Arduino software. If you already have an Arduino printed circuit board running, it is a good idea to go ahead and check the breadboard version you are building with a chip you know works. Pull the chip from your working Arduino and try it on this board. The Blink LED program blinks pin 13. So pin 13 on the Arduino is not the AVR ATMEGA 8 16PU. Pin 13, it is actually pin 19 on the ATMEGA chip that we are using here. So connect pin 19 in this chip to a LED to make sure that the Blink LED program works. by pulling the original chip from an Arduino board if you want to test this connection, and place the IC here. Now, as you can see, finally, at the lid, the long lid or the anode connect to the red wire, and the short leg or the cathode connects to the 220 ohm resistor going to ground. So let's examine it here. This is the wire. It's connected to the long lead. The short lead is connected to the 220 ohm resistor and to ground. Now if we took an IC from a working Arduino PCB or board and placed it here, it has already the blink lid program, so it will blink this lid and it will turn it on and off. This is how we make sure that our connection is good to go. Next we will talk about more details about the Arduino and how to program it. At this point, if you had already programmed your chip somewhere else and didn't need this breadboard circuit to reprogram the chip, you could stop here, but part of the fun is in-circuit programming, so keep going to really make a full USB Arduino circuit on a breadboard. So you can stop here, you can settle with this configuration. Whenever you want to test a new program, you can remove this chip and program it on Arduino board that you have, or you can have a friend program it for you. But for now, this chip cannot be programmed in circuit. Next steps, or in the next lessons, we will talk in more details about how to enable this Arduino board to be programmed using USB, just like an actual fully functional Arduino board. That's it for this lesson. If you have any question, please ask in the Q&A board. This is Educational Engineering Team.